In today's session, we'll study the chapter amines. The chief commercial uses of amine is as intermediate in the synthesis of many medicines and fibers. When one of the hydrogen atom is replaced by NH2 group, then it forms amines. RH, alkane, hydrogen is replaced by NH2. It forms amines. Amines are the important class of organic compound. They occur among protein, vitamins, alkaloids and hormones. Now, two biologically active compounds, namely adrenaline and ephedrine. They both contain secondary amino groups and are used to increase blood pressure. Novocaine, a synthetic amino compound, is used as anesthetic in dentistry. Benadryl, a well-known antihistamine drug, also used to reduce allergic reactions in the body. They contain tertiary amino group, and quaternary ammonium salts are used as surfactant, means that is cleansing agents, and diazonium salts are also prepared from amines. Now, amines are of three types. Primary amines are NH2. It is primary amine, means one alkyl group is present and it is primary amine. If one of the hydrogen is replaced by alkyl group, then it is secondary amine, and if both the hydrogen from nitrogen are replaced, then it is called tertiary amines. Now, the structure of amines. Structure of amines. Amines had structure similar to alkane. In this, the three hydrogen atoms are present. Just like alkane, it has tetrahedral structure. Similarly, in amines also, three alkyl groups are attached to the nitrogen atom with one lone pair of electron. So, bond angle here is 109 degree, less than 109 degree, that is 108 degree, due to the repulsion between the bond pair and the lone pair. Here it has 109 degree 28 minutes. The structure of amine is almost similar to the alkanes. Next is classification of amines. Now, classification amines, just now I told you that is primary, secondary and tertiary. If one alkyl group primary, two alkyl group secondary, three alkyl group tertiary. Now we will discuss the IUPAC naming of the compounds. IUPAC of amines. Now general IUPAC name is alkanamine. Means count the number of carbon atom and add amine by replacing E. For example, simplest member is CH3NH2. So we have replaced one hydrogen by NH2 group. Only one carbon is there. So we write down methane amine. We will not write down double A. It will be single A. Methana amine. Now, if it is present in this at the second carbon atom, then we will number it 1, 2, 3. So it will be propane 2 amine. If more than 2 functional groups are present, if more than 2 functional groups are present, then NH2 is taken as prefix. So it will be propanol and 2 amino propanol. Now secondary amine is named as N alkyl alkanamine. In this at N one alkyl group, that is CH3, is present. So we'll write down N represents nitrogen, N methyl methanamine. Both side 1 carbon is there. One is this side, one is so N. If suppose it is written as CH3 CH2 NH CH3, then its name will be N methyl ethanamine. Next is tertiary amine. Tertiary amine, it will be N dialkyl alkanamine. its name will be tertiary amines, CH3, CH2, N, CH3, CH3. So its name will be N, since both groups are same, 1, 1. Both the groups are methyl groups, so N dimethyl amine. Next, aromatic amines. Aromatic amines, it is called as either aniline, you can use aniline, or benzenamine, aniline or benzenamine. So second example we can take so we can write down as 4 bromo aniline, because this is complete is aniline and at fourth position Br is attached. Fourth position Br is attached, so it is called 4 bromo aniline. Likewise, we can do practice. Next is preparation of amines. Preparation of amines. First is by reduction of nitro group. By reduction of nitro group. When nitrobenzene undergoes reduction in the presence of hydrogen, palladium, ethanol, it forms aniline. It forms aniline. Reagent, second reagent which we can take is Fe plus HCl. This is the second reagent. Third reagent which we can use is Sn plus HCl. So reactants and products are same. Reactants and products are same. Nitrobenzene will form aniline. The reaction or reduction in the presence of Fe and HCl is preferred because the FeCl formed gets hydrolyzed to release hydrochloric acid during the reaction. Therefore, a very small amount is required to initiate the reaction. So, the second reaction is the preferable reaction. Next is ammonolysis of alkyl halide. Now, the alkyl halide reacts with ammonia to form primary amine. Again, the second molecule of alkyl halide combines to form secondary amine. Third molecule of alkyl halide combines, so it will form R3N tertiary amine, and a fourth molecule is allowed to react. It forms quaternary ammonium salt RX. Quaternary ammonium salt. Now this reaction is not preferred because we get mixture of primary, secondary, tertiary and quaternary salt. Therefore, this method is not preferred. Now, if we want to get back primary amine from this salt, we allow to react this quaternary ammonium salt with NaOH. It forms primary amine plus H2O plus NaX. So this method is not used because we get the combination of all these amines. The order of reactivity of alkyl halide with amines, order of reactivity of alkyl halide with amines, Ri is greater than RBr is greater than RCl. Next is reduction of nitrile. Next is reduction of nitriles. Nitriles on reduction forms primary amine. Nitrile on reduction forms primary amine. This method is used to increase the number of carbon atom. Next is reduction of amides. Now, when amides undergoes reduction in the presence of lithium aluminum hydride, this reagent is a versatile reagent, can be used for reduction anywhere. It forms in this, when amide undergoes reduction, it forms same number of carbon atom. Next is Gabriel thalidomide reaction. Gabriel thalidomide reaction. Now in this reaction, thalidomide reacts with KOH. This is we have studied PHTHALIMI. In carboxylic acid we have prepared this compound. So thalidomide, when reacts with KOH, it forms potassium salt of thalidomide. Now this reacts with alkyl halide. It forms N-alkyl CO N-alkyl thalidomide. This reacts with NaOH to form sodium phthalate and so by this method we can prepare only primary amine, sodium by this method we can prepare only primary amine. And last method of preparation is Hoffman's bromamide reaction. Hoffman bromamide reaction. This reaction is used to reduce the one carbon atom from the amide. So when amide reacts with bromine and NaOH, it forms RNH2 plus sodium carbonate plus sodium bromide plus H2. Very important reaction used in conversion, or that is having one carbon less. If we want to prepare one carbon less, then we use this reaction. So next is physical properties. Now physical properties, first is physical state. The lower aliphatic amines are gases with fishy odor. Primary amines with 3 or more carbon atoms are liquid and higher members are solid. Aniline and other aryl amines are colorless but can develop color by atmospheric oxidation. Therefore, aniline is stored in colored bottles. Second is solubility. The lower aliphatic amines are soluble in water because they can form hydrogen bonding with water molecule. The solubility decreases with increase in molecular mass, or that is, you can say, that is increase in the size of alkyl group. So higher members after carbon 10 are insoluble in water. If we compare the solubility of, that is, amines and alcohol, then alcohol are more soluble than amines because the electronegativity of oxygen is higher than nitrogen. So whenever we will compare, then always alcohols are highly soluble than amines. Now if we compare the solubility of primary, secondary and tertiary alcohol, then primary alcohols, they are more soluble because 2 hydrogen atoms are present, so it can form 2 intermolecular hydrogen bonding as compared to the secondary, and tertiary will not be able to form. Therefore, the order of solubility, or you can say the boiling point also, the boiling point will of the primary amines will be higher as compared to secondary and tertiary. So in today's session we have studied about the introduction, structure, IUPAC naming, method of preparation and physical properties of amines.